Today we are going to look at applications of integration. So one of the things I kind of want to go through to start is something we've looked at before, and I'm just going to write it up here. And it's this idea of displacement. Now, some of you who do physics will know a lot more about this than me and than the rest of us perhaps. Basically, displacement is the action of something moving, okay? And the easiest way I think of it is like a distance to get from one point to another, okay? Now, before I go into the integration bit of this, something to note is that if you have, I'll call it displacement, but if you want to think of it as distance, that might be easier. And if you think about it, if you move from A to B, or you travel down the road, or you travel to Galway, the rate at which you're traveling is the rate of change at which you're traveling is called your speed. So if you want to work out the speed rate of change, what you do is you're going to differentiate. So to get from there to there, I'm just going to write here to make it easier, dy dx. You differentiate, right? To get from there to there. And then if you wanted to find out the rate of change of your speed, so if you get into a car and you hear your mom or your dad revving the car, if they go faster, the speed speeds up, or if they go slower, that's called acceleration. Hope I'm spelling that right. And how you find that, because it's the rate of change of speed, is you work out the second derivative, differentiate your speed, and d2y over dx squared is what it can be called. Okay. Now, if you, as we have been doing, we've been integrating, which is the reverse process. So if you want, let's say you have acceleration and you want to find speed, so you go, no, that's permanent. Sugar, 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 sugar. Don't use that. I was warned. This one's whiteboard. If you go back up that way, okay, so you're going from acceleration to speed, what you're going to do is you'll integrate. Okay, and similarly, if you want the displacement, distance, let's say, you would also integrate. Spelling wrong. Okay, so why this is important is you could be given questions either way, but for the purpose of this, we're mostly going to be dealing with going backwards because we're doing integration at the moment, okay? So what I'm going to do is I'm going to do an example of one. So on page 76, I'm going to do question 2. Right, now this gives you, by the way, another thing to note here, this could be also called velocity. Speed can be also called velocity, okay? And one other thing to note, and I said it at the start, is displacement is usually signified as an S. Speed and velocity is usually signified with a V, okay? It's a bit annoying that the S is the letter because like S sounds like speed, do you know, that type of way? So I find that a bit annoying. But anyway, right. So this one says it gives you a speed or a actually it says velocity, which they say is ds dt. Now that's very similar to doing dy dx, but now we're just saying the rate of change of the displacement in terms of dt is time, and we've dealt with that before. And they tell you that it's t squared minus 4t plus 3. Okay, now the first question says find the acceleration when t is equal to 5. They've given you velocity or speed, they want acceleration. So we need to think we're going down this way, which means I'm actually differentiating here. So even though we're in the integration chapter, they're asking me to differentiate. So what I'm going to do is I'm going to find d2s over dt squared. That's the notation. Don't worry too much about that. As long as you're able to do it, I don't think you'd be docked marks if you don't show that notation. So we're going to differentiate this here. That's going to be 2t minus 4. Okay. Now, they asked you to find the acceleration when t is equal to 5. So, no, I'll write, apologies, at t equals 5. We're going to just sub that in here. 2 by 5 minus 4, which is equal to 10 minus 4, which is 6. And the units there are meters per second. Second squared. Okay. Now, the second bit then says to, I can't remember actually what the question is. Where is my book? No, I don't have it with me. Yous will have it in front of you. It's question 2, part I. Sorry if you can see Rhonda. There's a spider in the corner of this room behind a bicycle that she's trying to get at. So that's what she's doing. So this one, I think, asks you, Rhonda, stop. That wasn't me kicking her. I was just pushing her with my foot to stop her from digging the carpet, which she has destroyed everywhere else. So this one gives you the I remember now. The question asks you to find the distance or displacement. Sorry. And it gives you, I think, it just asks you to find the displacement and to write S in terms of t. So that's what we're going to do here is then we're going to integrate our function here because we're going from here, this is what we have, velocity, backwards. So we're going to integrate. So I'm going to integrate t squared minus 4t plus 3. Now it's a lovely function to integrate. So the first one, t squared will become t cubed over 3 minus 4t squared over 2 plus 3t and plus your c. Okay, sorry, it's a bit messy there. So that's your integration, your integral of that. Now they told you, they gave you a point here, and that was so we can find out what c is. So they gave us the point where t is equal to 3. Oh no, sorry. T is equal to 3 and s is equal to 4. Okay? I'm going to continue this. I need to just get her out of here.